Hello, this is Mrs. Butcher, and this is video 6.2-11, the last one of this chapter, logarithmic application problems. So that just means your favorite word problems. And we're just going to do 4 example word problems in this video so you can see how to set up your logarithmic problems or your logarithmic equations from the word problems, and then you're going to solve them using the skills that you've already got. Okay. So our first example, you invest $2,000 in an account that pays 5% interest compounded continuously. How long will it take for your money to triple? All right, so we're going to use the continuously compounded interest formula, and don't worry, I will give this to you on the test. A PERT, A equals P e to the RT, and we're going to fill in all the values. Our A is our after amount, and we want $2,000 to triple, so that means multiply 2,000 by 3. Our after amount will be $6,000. Our prior amount was the 2,000 that we started with. Then E raised to the rate, which is 0.05, and then the time, T, and that's what we're trying to solve for. So the first thing we want to do, just like we always need to do, is isolate the exponential part. So we need to divide both sides by 2,000. And that gives you the 3, which is where the triple came from. So 3 equals e to the 0.05t. And I'm running out of room. That's okay. So now what I want you to do is rewrite this so that the e part, the exponential part, comes first and the answer comes second. So I'm going to go to another page. All right, so we have e to the 0.05t equals 3. And the reason I'm having you rewrite it is so that it is in Ben form, base to the exponent equals number. Because then we can rewrite it in Benny, log base b of n equals e. So we're going to say log base e of 3 equals 0.05t. And then you know that log base e is the same thing as ln, so ln 3. And then to get t by itself, just divide both sides by 0.05. Make sure when you put this in your calculator, it's going to open a parenthesis there. You make sure you close it and then divide by 0.05. And you will get a time t equals 21, and I want 3 decimal places, so 0.972. And then these interest problems are always in years. 21.972 years. That is a long time. But you don't have to do anything but put your money in there and let it sit. So, sounds good to me. Okay, second example. A washing machine is purchased for $400, and it decreases in value at a rate of 20% annually. After how many years will the washing machine be worth $40? All right, I did this problem in the spirit of the fact that I just now bought a brand new washing machine. Okay, so we are going to use the formula y equals a, 1 minus r to the t. And don't worry, I will give you that on the test as well. That's the decay formula. So we're going to plug in our after amount for y, so 40 equals, that a is your prior amount, so 400, times 1 minus 0.2, because that's your rate, raised to the t. So the first thing we have to do is isolate the exponential. So I'm going to divide both sides by 400. And 40 divided by 400 is 0.1. So 0.1 equals, and then 1 minus 0.2 is 0.8. So I'm just going to go ahead and make that 0.8 raised to the t power. And then if it helps you see it, rewrite it as 0.8 to the t power equals 0.1. So that we have it in Ben form, base to the exponent equals number, and then change it to a logarithm. Log base 0.8 of 0.1 equals t, right? Log base this of this equals this. So this can be punched in your calculator, and you will get t equals 10.319 years. In 10.319 years. Those things don't hold their value very well. Alright, next example. This one I found in a book, so I don't know if this is true or not, but researchers have found that after age 25, the average size of a person's pupil decreases. The relationship between pupil diameter, d, in millimeters, and age a in years can be modeled by d equals negative 2.1158 natural log of a plus 13.669. What is the average age of people who have pupils with a diameter of 6 millimeters? Alright, so we're going to just fill in all the spots in this equation. The d is our diameter, so that's 6. And then we have negative 2.1158 ln a is what we're trying to find, plus 13.669. Alright, so we need to isolate the logarithm and then rewrite it as an exponential. So the first thing we have to do is subtract 13.669 from both sides. Whoops. And so 6 minus 13.669 gives us negative 7.669 equals negative 2.1158 ln a. Then we are going to divide both sides by negative 2.1158. When you do that division, we get 3.625. And remember, when you're doing this in your calculator, make sure you're using second answer, that you're using the full number and not rounding every time you retype a new step. Use second answer. It will totally change your answer if you round every time you take a step, and then you'll get it wrong. So 3.625 equals the natural log of a. And I'm going to go on to another page so that we can see. I want you to rewrite it with the natural log first. Natural log of a equals 3.625. That way you can see it in Benny form and rewrite it in Ben form. So the base on the natural log is e. See, you can put it right there, right? You're going to raise it to the 3.625 power and then equals a. And e raised to this 3.625 power you can do in your calculator, and you get 37.511 years old. Hey, that's how old I am. So I guess my pupil's probably about 6 millimeters. That's pretty cool. Okay, last one. I thought I'd do a little St. Patrick's themed one here. We've got the population of leprechauns in a forest can be modeled by the equation p equals 50 plus 200 natural log of t plus 1. And note that that t plus 1 is in parentheses, where t is the time in years from the present. In how many years will the leprechaun population reach 500? So we're going to plug in a 500 for p. Population 500 equals 50 plus 200 natural log t plus 1 in parentheses. Alright, so we need to isolate our logarithm. And in this case, the t plus 1 all goes with the logarithm. So the first thing I'm going to do is subtract 50 from both sides. And I have 450 equals 200 ln t plus 1. And then I'm going to divide both sides by 200. And 450 divided by 200 is 2.25. So 2.25 equals the natural log of t plus 1. So now our natural log is isolated. Write it first. ln t plus 1 equals 2.25. And if it helps, put the little e there so you can know what the base is. And we're going to say e raised to the 2.25 power equals t plus 1. And I'm going to put that on the next page. E raised to the 2.25 power equals t plus 1. So if we want to find t, we need to take 1 away from both sides. Don't take it away from the exponent. It's e to the 2.25 power and then a big fat minus 1 equals t. So you just punch that number in, punch e to the 2.25 in the calculator, take away 1, and we get a time of 8.488 years. So in about 8.5 years, there will be 500 leprechauns in the forest, which sounds just fabulous. Okay, guys, have a great spring break and a good night, and I'll see you when I see you.